Hello everyone, hope you are doing good and welcome back to my channel. Today we are at problem of the day 7 for January month and Geeks for Geeks. Okay, so in this particular question, basically it is of hard level, and if you see, this is one of the prominent questions being asked by companies such as Google. Okay, so we will see what this question is, and this is, I think, for the first time in this month, we are going to have a questions on the binary search. Okay, how we will know that, we'll surely discuss on that, but let's see what the question is. The name is split arrays largest sum, and the question is given an array, that is the name of that is arr, it has n elements, and we are given an number k. Okay, as you can see, split the given array into k subarrays such that, remember we are talking about subarrays. I hope, see, whenever I hear this word, I always talk about the difference between subarrays and subsequence, because believe me, these things are very very common in interviews. Okay, so if you get such a question, the first thing the interview will ask you is what is a subarray and what is a subsequence. Okay, so please know the difference between them. So by the way, we are here given k subarrays such that maximum subarray sum achievable out of the k subarrays formed is to be minimum. Okay, so what they're saying is split the given array into k subarrays such that maximum subarray sum achievable out of the k subarrays formed is minimum. Find the possible subarray sum. I am sure you would not have understood much by reading it, one or two times. But let's see the example that will make more sense. Okay. So in this case, what you are seeing is, see, one thing is very clear. Whatever is the value of k given to us, that means subarrays we need to make. Okay, that is the basic idea. And when we do that, see, obviously, k subarrays I need to make. That is clear. Now, next thing is what will be the individual sum of those subarrays. Okay, so the idea here is to have the minimum possible subarray sums. Okay, that's what they're trying to say, such that the maximum subarray sum achievable out of the k subarrays formed is minimum, that is c. I have three subarrays now, right? Why I have three subarrays? Because k is 3. Okay, so what is the sum now? What is the maximum subarray sum now? It is 3. Okay, it is also 3 and it is 4. Okay, so what is the maximum subarray sum? In this case it is 4, right? That's why they're mentioning maximum sum of all subarrays is 4. Okay, maximum sum among the subarrays is 4. Okay, now I have to minimize this number. Okay, so they are saying maximum subarray sum achievable out of the k subarrays should be minimum possible. So we should be proving that 4 is the minimum possible. As simple as that. Okay, which is minimum possible out of 3 splits. Okay, that's what they're trying to say. So see, in this particular case, there are only 3 splits possible. That's why they are saying that 1 comma 2, and yeah, that's what they have done actually. You can have 3 comma 4 also at the same time, or you can have 1 2 3. Yeah, in that way, you can see those ways. Okay, in whichever way you can split. So the idea here is to have 3 values or such. Okay, so we'll say that that also. So yeah, let us see first how many ways you can divide. See, there are 3 ways to do it. See, I can take 1 and 2 together, then 3 and 4 separately. Okay, that is one way. I can take 3 and 4 together, and then 1 and 2 separately. Okay, that is another way. I can have 1 separately, 2 and 3 separately, and 4 separately. Okay, so that is the basic idea. But you will see that in all such cases, for example, when I have 2 and 3 common, the maximum sum of among all the subarrays is going to be 5, right? And similarly, in this case, when I have 3 and 4 common, obviously the answer is 7. And similarly, when I have 1 and 2 common, the answer is going to be 4. So that's why they're trying to claim that 4 is the minimum possible. Okay, the minimum possible maximum subarray sum achievable out of the k. I'm sure you would not have understood till now, but see, try to understand what we are saying. We have to form k subarrays. Okay, I think this point is very clear to you now, right? We have to form k subarrays. Okay, now among those subarrays, try to find the sum. Okay, for example, it is 3 in this case, it is 3 in this case, it is 4 in this case. Okay, so the idea here is among, see, the subarray sum among the subarrays. Okay, whatever is it, that take the max of that. In this case it is 4. Okay, that should be the minimum possible. Okay, that's what they are trying to say. Okay, and you will have to return that as the answer. That should be the answer. Okay, you have to minimize. Okay, you have to minimize the maximum subarray sum achievable. Okay, I hope you have answered the question now. So how to do that we will see, but okay, let me ask you a few questions here. Can you quickly tell me what is the smallest in this case possible? Okay, see, we'll just discuss it. Okay, don't worry. It's not like the answer here finally, but just think. See, among them, what is the highest number? Obviously 4, right? So the idea here is any subarray. Okay, any subarray in this case. If you take the maximum of the sum of among all the subarrays, obviously the answer will be either 4 or greater than 4. Why like that? See, if I combine any element with 4, okay, obviously the sum is going to be greater than 4, right? And if I take 4 individually, obviously still the sum is going to be 4 only. right? So the answer is at least 4, or anything above 4 is obviously possible. So the starting point is definitely 4, right? Similarly, do we have any end point, like what can be the max sum possible, like that? So the max possible can be like sum of all of these, okay? So we can take that as a very safe, answer, okay? So we are discussing two things here, right? See, whenever such a question comes, we have to, arrange the range among which the answer can be lie, okay? So if I take the max of all the elements individually, I will get 4, right? That could be the, lower limit for my answer. And if I take the sum of all these elements, by the way, the sum is 10 in this case, okay? Sum of all these elements, so that can be the max limit of my answer, okay? So the answer which I'm going to output is going to lie in that range. Once I know that, as you might be aware, this is the hint for using binary search approach. We'll see that what it is. Let's see what we're doing, okay? So yeah, here we are. So first idea is very clear. I will be finding what is the max element, and then I will be trying to find what is the total sum. Okay, these two things we are doing. Okay, so first let us do those things first. So max element I am initializing with 0. Total sum I am initializing with 0. Okay, I'm writing a for loop. I'm going to every element in the array, and I am updating these two variables. Okay, how we are doing that? Let us see. Total sum is equal to total sum plus I. That is very simple way of finding the total sum. And max element is equal to max element of the previous max element comma I. Okay, so we are updating max element whenever we find a greater integer. As simple as that. I have defined a function here. Okay, yeah, this is the one. So yeah, the function is here from here to here. Let me quickly show you what it means. But before that, let's see the rest of the part. Okay. So I hope why we are doing binary search is very clear to you, because see, whenever if we know the answer is going to lie in a certain limit, okay, and that limit is in the ascending order, the first the thing that should strike your mind is binary search. Okay. In this case, why we are doing that, it's clear, right? See, they are asking about the maximum subarray sum. Okay, and we have to make it as much minimum as possible. Okay, so one thing is very clear. See, whichever subarray you make, always 4 will be in some subarray, right? At least you will accept that fact, right? Either 4 can be alone or 4 can be with something else, right? So the minimum possible answer will start from 4 itself. Okay, and what could be the maximum possible answer? You can, as a safe limit, though this is not going to happen, but as a safe limit you can say that sum of all of these. Okay, so this is what we are going to do. I hope you have understood the logic here. And in binary search, whenever we do that, you must be knowing that there has to be a starting and there has to be ending. Okay. So in my case, I have set the starting as the max element, that is the 4 in this case, and I have set the end to be the total sum, which is 10 in this case. Okay. This is my answer variable. Okay. What is this answer, by the way? This is going to be the minimum possible maximum subarray sum achievable. Okay. I hope I I hope I am making sense, and it's very logical. Minimum possible maximum subarray sum achievable. Okay, so this is going to be my answer, because if we are trying to find a minimum value, that's why we initialize it with the maximum possible value. Okay, so let's see what we're doing. So see, now one thing is that while finding this, we will using this particular function. What this function is, by the way? See, idea is very simple. I will decide a sum, okay, between 4 and 10. I will pass that value here, okay. And when I set this as the value, I will try to see how many, subarrays we need to make, okay. What that means is, for example, see here, suppose I set 5 as the maximum subarray sum achievable, okay. That means any subarray which is having a sum greater than 5 should not be, taken. We have to break the subarrays before that itself. What that means is, let us see with the example. For example, in this case, let us take 3 as the example. What that means is, if a subarray sum exceeds 3, break it and try to make a new subarray. Okay, let us see. Is 1 exceeding 3? No. Okay, I can have 1 and 2 together. That means, okay. So 1 and 2 together makes 3. That means this is the end. Right? I cannot extend this subarray. Okay, what is the next? It can be 3. Okay, 3 is there, and again I cannot extend 3 further because I have reached the limit. Next can be 4. I hope you are trying to understanding what I'm doing. See, I am going to see, I know that the answer is going to be between 4 and 10. Okay, but what is the answer? How to check that? So for that reason I am doing this. Okay, I will decide a value which I will set as the maximum subarray limit. Okay, I am doing trial and error method here. Okay, suppose if I set a number as 3, then I will check if this sub how many partitions I will make out of it. Okay, See, when I set 3 as a target, what that means is a subarray sum should not exceed 3. As simple as that. That is what is being done here with this. This is the max sum array sum passed here. Okay. So if any subarray exceeds 3, I will break that subarray. Okay. As simple as that. This function calculates the number of subarrays if max subarray sum is this particular value. Okay. I have mentioned in comment also. It returns true if the number of subarrays is less than equal to k. It returns false otherwise. Okay. So that's what we are trying to check here. So yeah, these are the two variables already declared. See, non-local means whenever you are in a function scope, that is, whenever you're declaring function, you will have to mention the non-local values. Okay. Otherwise, the function will assume that these values are defined in our function itself, and it will be initialized with a null value. That's what it is. Okay. So this is going to be the count of the subarrays, and this is going to be the sum of the subarrays. Okay. Let's see what we're doing. It's a simple for loop. Going through all the elements of the subarray. Okay. If the sum plus I, okay, what is I is the element in the subarray. Okay, if the sum plus I is less than equal to this particular value, then proceed. Okay, increase the sum. Otherwise, what you have to do, you have to break it out. Okay, remember I am starting count with 1. Okay, so the count will increase. That means I am going to the second subarray now, and I will start the second subarray with the value I. Remember, see the difference here and here. Okay, see the difference here and here. Don't worry, I will trace and show you. I have done a lot of work here. All the print statements and all the tracing I have already done here. Okay, so don't worry, that also we will discuss. Okay, but for now just see this. So whenever we exceed this limit, what we have to do, we have to break the subarray and start a new subarray. So I will increase that count here. This count will be the number of subarrays we are making. Okay, and I will set the sum to be I. Remember, it is starting from I, not plus equal to I. Remember that. Okay, then what I will do, I will just return if this count is less than equal to k. Okay, if the count is less than equal to k, as simple as that. Now let's come to our binary search. I'm starting, start is set to the max element, which is 4 in this case. The end is set to the total sum, which is 10 in this case. Okay, just count what is the sum of all this. It is 10, by the way, the sum of all of this. Okay, I have set the answer to be a infinite value. Why? Because we are trying to find a minimum value, so it's making sense to make it infinite. Okay, what next? This is the basic setup for any binary search function. While start is less than equal to 1, do this. I will find a mid value. Mid value will be somewhere in between the start and the end. Okay, what I'm doing, start plus and minus start whole divided by this. Remember, this is the integer division. Only the integer part will be retained. So don't worry, we will trace it out what it means. Everything will trace it out. For now, just see the code. Okay, then I am passing this value to this particular function. Okay, it will return. See, idea here is try to understand what we are doing. If you set the limit very small, okay, if you set the limit very very small, for example, if I set the limit as 1, okay, okay, yeah, if I set the limit as 1, what will happen? Let us say not 1, let me say 2. Okay, if I set the limit as 2, then it will be breaking every now and then. Okay, so what will happen is this will not be true in that case. Okay, this function will not be true. We'll be having a lot of partitions which is exceeding k. Okay, that is the basic idea. So what that means is we need to increase our mid value. That is what it is. This is the case, increase mid value. If the number of partitions is less than k, that means we are having a very high mid value. We need to reduce the mid value. Okay, check if we can reduce the mid value further. This is what it is. Okay, so this is the basic logic which we are using. If you are seeing this for the first time, I'm sure you won't be understanding it, but please try to understand. At least after seeing the tracing part, I'm sure you should be able to understand it. Okay, idea is very simple. After I pass to this function based on the return value, see, return value will be true or false, right? True when it is the number of partitions is less than equal to k. False if it is greater than equal to k. Okay, so if it is less than equal to k, what that means is we need to see if we can reduce the mid value further. We have got the answer. Remember that we have got the answer, but still, see, mid is actually a possible answer, but we still should see whether we can reduce it further, because remember, we want the minimum possible value, not any value. Okay, so what I will do, first of all, I will reduce n by 1. Okay, why I'm reducing n by 1? See, this is again a logic of see, this is binary search logic basically. This is not very specific to this question. Always we will do that in binary search. Okay, what we're trying to do is this: we're trying to reduce the mid value. Okay, if we do this, the next mid value which will come by this division will be very less. Okay, as simple as that. You will see that in the tracing also. After that, since mid can be a possible answer, I am taking answer of, yes, I am just seeing if it is smaller than the previous answer. I am updating my answer. Okay, if I come to the else part, what is the else part, by the way? If I get to know that this particular condition is not true, that means the number of partitions appearing is much greater than k. Okay, what that means? That means we are have sent a very small maximum array. Okay, so we should try to increase it. How should I increase it? I should change this side as mid plus 1. Remember, here we're changing the mid the end as mid minus 1. Here we are changing the start as mid plus 1. Okay, that is what it is. I hope you understand what we are doing. See the idea here. Okay, let me quickly do this and show you. See, we are have two things. Okay, start, mid, and end. Okay, so if I realize that, see here, just a second. See, if I realize, see, this is the start. Okay, mid will be between the start and end is the end. Okay, if I realize that the number of partitions is too many. Okay, so what I should do, I have to reduce. Partitions are too many. Okay, so I have to basically increase the mid value. Okay, what that means by increase the mid value, what that I will do is, I will this start, I will do that, like I will make it mid plus 1. So start will come here now. Okay, then I will find a new mid. Okay, as simple as that. So you understood, right? That what that means is the next mid value which will come between the start and end will definitely be a much greater value. As simple as that. Okay, I hope you're understanding what I'm saying. In the other case, what is the other case? What we're doing is, if the number of partitions is less than k, what that means, we have already set a very high value. What I should do next? What I should do next? I should try to find a value which is slightly less. Okay. So what I should do? I should reduce the end as mid minus 1. So end will come here now before mid. Okay. So a new mid will be found which will be between start and end. Okay. So definitely the next mid will be much less than the previous mid. Okay. That is what I wanted to show you. Okay. So yeah, that is there, and that's what we're doing. And remember, in this case, we are not computing the answer. Why? Remember, we have to get k partitions, right? If we are getting any partition which is greater than k, obviously that is not going to be the solution. We have to still dig in further. That's what the idea is. This follow will continue, still start is less than equal to end. Now once we come out of this thing, we will return the answer. Okay, let's quickly trace it out. I know this will make sense only if we trace it out. Okay, let's see what we're doing. So in this example, it's very clear the maximum element is 4. Okay, so that will form my starting part. Okay, I hope this makes sense. So see, I've already labeled it. The first number which you see here is the start, the middle number which you see is the mid, and the last number which you see is the end. Okay, let's see now. So 4 is the starting part. Okay, what is the sum of all of these? 10, right? So 10 is the ending part. I will again repeat my approach here. Why we are doing binary search is because we know the answer is going to lie between 4 and 10. That's why we are doing binary search. Now how I am getting 7 here, let us see. So this is the formula for mid. Okay, 4 plus 10 minus 4 integer division by 2. So what is 10 minus 4? 6. 6 by 2 is 3. So 4 plus 3 is 7. Okay, so 7 is coming here. Okay, as simple as that. So if you take mid as 7, what that means is, try to form a subarray till the sum is less than equal to 7. What that means, I can have 1, I can have 2, I can have 3 also. Okay, what is 3 plus 2 plus 1? It is 6. Okay, less than that. After that, I will break this subarray because I cannot add 4, and for 4 I will have a separate subarray. So total we are making 2 subarrays. 2 is less than equal to 3. Okay, so this is a possible solution. We'll execute this part of the code. Okay, answer will be updated. Answer is equal to minimum of the infinite value comma 7. So answer will be made as 7. But since we will still try to see, check if we can reduce the mid value further. What we will do, we will do and equal to mid minus 1. What will be end now? 7 minus 1. What is 7 minus 1? It is 6. Okay, it will be 6. 4 will remain, the start will still remain 4 only. Remember that. We will now compute a new mid. What is the new mid? 4 plus 6 minus 4. So see, this is the formula. Okay, 4 plus 6 minus 4, integer division by 2. Okay, so what is 6 minus 4? It is 2. 2 divided by 2 is 1. So 4 plus 1 is 5. Okay, so this will be my new mid. Okay, so when I have 5, let us see. Don't worry, I will print and show you. Here I have given a print statements. I will show you that what it means. But for now, just see the the manual way of doing it. Okay, so if I set the maximum subarray sum limit as 5, what it means? So see, these two I can have. What is the sum of these two? 3. Okay, 3. If I take this also, what it will become now? 3 plus 3, 6. Is 6 less than or equal to 5? No. What that means is, the array subarray will end here. This will be a separate subarray. Okay, and this will be a separate subarray. So how many subarrays? Sorry, yeah, what is the count of subarrays? We are having 3 subarrays. Okay, so is 3 less than equal to 3? This part, yeah, it is 2. So again, this part will be executed. Same part will be executed again. Okay, so we will. What is the answer now? Answer equal to minimum of 7 comma 5, which is 5. Okay, and obviously we'll do and equal to mid minus 1. What is mid in this case? 5. What will be and now, which will be 5 minus 1, which is 4. Okay, it will be 4. Remember, what is the starting, what is the entry condition here? It is start less than equal to end. Okay, is 4 less than equal to 4? Yeah, that is true. 4 is less than equal to 4. So the new mid will be calculated. What is the mid? 4 plus 4 minus 4, integer division by 2. This whole thing will become 0. So we'll have 4 itself. So mid also will be 4. So for what we can do, see here. Again, these two can be taken, okay, because the sum is 3, it is less than equal to 4. I cannot take 3 and with 1 and 2 because it will become, 6. 6 is not less than equal to 4. What that means is these two will be a subarray, this will be a separate subarray, and this will be a separate subarray, okay. So we'll have 3 subarrays, okay. In this case, as you might be knowing, what is the max sum array, max subarray sum, max sub, yeah, that is 4, right? So we will do that, okay. We will do this also, and equal to mid minus 1. So what will be the new end, we can do that. See, start will remain the same, okay. Start will remain the same. What will the end now? End will be 3, okay. Now this condition we will check. Is start less than equal to end? Is 3, sorry, is 4 less than equal to end? Obviously no. So this loop will break, okay. Yeah, while loop will break here. Okay, no mid will be calculated, okay. So once we come out of this loop, what will happen? I will return the answer. What is the answer, by the way? 4. So 4 will be returned, okay. This is what we are doing here, okay. I hope you have understood why we are using the binary search approach. And yeah, that's what it is, because in this case that the answer can be between the max element and the total sum of all the elements. That's why using the binary search. Let me quickly run this and show you what it looks. I, by the way, given some comments that also we'll discuss. So yeah, this you can see. When I pass 7, maximum subarray equal to 7, how many arrays I am getting? 2. When I pass as 5, how many I am getting? 3. This is what I already discussed, right? If I pass 4, what I am getting? 3 again, okay? But since after 3, this loop stops, okay? So we are returning finally, 4 as the answer, okay? This is the final answer. Let me quickly, comment it out and let us run the code and see. This code I have already submitted and it works. You can do the same. So often, as you can see, this works, okay. So often, that was all for today. I know it's a hard question, but believe me, if you want to target these kind of companies, you will have to go through this, okay. This, by the way, if you know the logic, if you get comments from the interviewer, I believe this is solvable. So often, that was all for today. We will meet again tomorrow. Thanks a lot.